This lesson is about circular functions, and we're dealing with functions that can be any number represented by any number, and we'll call that number s. But basically, we're used to thinking of this as an arc along, corresponding to a central angle. We'll call the angle still theta because we're used to that, on a circle. And what this leads to eventually is that functions like sine and cosine can be used to describe things in nature, and they can be a function of any number, and the number can just be s. And the things that we're describing don't have any relation to actual angles, but they still can be written with trig functions. So anyway, we have the unit circle, radius of 1. The terminal side of the angle goes through a point xy that's 1 away from the center of the circle at 0, 0. And we can describe this equation with this unit circle with the equation x squared plus y squared equals 1. And where that comes from, in geometry you learned that a circle was a bunch of points, xy points, that were all a fixed distance called the radius away from the center of the circle. So the coordinates of the center of the circle, the x and y coordinates, were a and b, and the radius was r. And xy could be any point, and it was a fixed distance of the radius away from the center at 0, 0, or in this case at 0, 0. So if I replace the center of the circle, those coordinates a and b, with zeros, and the radius with a 1, I get this equation. It reduces to x squared plus y squared equals 1. So the unit circle has its center at 0, 0 and a radius of 1. And what would happen if we have an angle that just say goes through xy, we can start at xy and draw a little reference right triangle like we always have down to the x axis. And then because this point is to the left by x and up by y, this distance here, the bottom of this reference triangle, is x, and this vertical distance is y. And remember that this radius of this triangle is 1. So again, just using Pythagorean theorem here, we get x squared plus y squared equals 1 squared. Again, x squared plus y squared equals 1 defines the unit circle. So what happens is, if I look at this as now my reference angle theta, and I want to know the sine of this angle, the sine is y over 1. And if I want to know the cosine of this angle, the cosine is x over 1. So what happens is this ordered pair in x and y tells you the cosine is x and the sine is y. So those values actually give you the sine and the cosine. Because the radius is 1, we're just dividing both of those by 1. So when the radius is 1, the points x, y give you the cosine of the function of the angle and the sine of the angle directly. So in a unit circle, the sine of theta is always equal to y, and the cosine is equal to x, and the tangent is y over x, or the sine of the angle divided by the cosine of the angle or function. And the cosecant is the reciprocal of sine, so it's 1 over y, or 1 over the sine. The secant is the reciprocal of the cosine, so it's 1 over x. And the cotangent's the reciprocal of the tangent, so it's x over y, or we could think of this as the cosine of the angle over the sine of the angle. Now, because x is cosine of theta and y is the sine of theta, we can replace this with the cosine of theta, and we write the squared here next to cosine in this equation, and we can replace y with the sine of theta in the equation, and we have this important trigonometric identity that the cosine squared of theta, or the function, plus the sine squared of the function equals 1. Again, this all comes from the distance formula and the equation of a circle, which does come from Pythagorean theorem. Okay, so now with numbers, to make some sense of this, we'll do an example. So we're asked to find the exact values of the 6 trig functions of a given number. And let me go back for 1 minute to describe what we call this a circular function, because we imagine a point or a particle starting at this point 1, 0 and traveling along the arc of the circle here and stopping at a certain point. And then these functions they end up repeating themselves over and over as you go around and around the circle. So the function s is this distance that I travel here. Okay, so to find the exact values of the 6 trig functions for 2 pi over 3. So we're given that that's the angle measure. So let's convert that to degrees so it's something that's familiar to us. So I can convert that to degrees using the multiplier with pi in the denominator and 180 degrees in the numerator, and the pi's cancel, and 180 divided by 3 is 60 times 2 would be 120 degrees. So this is a familiar 120 degree angle. So it's going to terminate over in quadrant 2, about like so. Okay, remember its radius is 1. And if we recall the little memory helper all students take calculus, we know that in quadrant 2, because we go left on x and up on y, that cosine will be negative. Well, this tells us sine is the only positive basic function in that quadrant, for starters. Okay, so what we need to do is figure out the coordinates of this point, x, y. And that's because when we do, this will tell us the cosine, and this coordinate will tell us the sine of this angle. So again, oops, this whole thing is, let's go, 2 pi over 3, or 180 degrees. So what we know is that when we draw the little reference triangle, that this reference angle, if this is, oh, I'm sorry, this isn't 180, this is 120 degrees. We know that this, if this is 120, that the reference angle down here must be a 60 degree angle. So I'm going to redraw that triangle out to the side. Okay, so if this is a 60 degree angle, then this is a 30 degree angle. And if this radius is 1, then I know the short leg here is 1/2, it's half of the hypotenuse, and this leg is short leg times root 3, so this is root 3 over 2. So now I'm going to put those back into the triangle, but I'm going to remember that since this was the origin, I moved left, so this has got to be a negative. So this distance is negative 1/2, and this distance is root 3 over 2. So that gives me my x coordinate of the point, and this gives me my y coordinate. And now I can find my 6 trig functions. So it's this ordered pair that you're trying to find that gives you all the values you need. So writing these in. So the reciprocal of sine is the cosecant. The reciprocal of cosine is the secant. And the reciprocal of the tangent is the cotangent. Okay, so the sine is the y-coordinate, root 3 over 2. The cosine is the x-coordinate, negative 1/2. The tangent is at y divided by x, or sine divided by cosine. When I divide these, the 2's will cancel, and I'll get negative root 3. And we're giving exact values, right? Because this is one of the special, this is a 30, 60, 90, the 60 degree reference angle is a special angle. So we want to always give those values exact. Okay, so the cosecant is the reciprocal of this, so it's going to be 2 over root 3, which will be 2 root 3 over 3 when I rationalize that denominator. The secant is the reciprocal of negative 1/2, which is negative 2, and the cotangent is 1 over negative root 3, which simplifies to negative root 3 over 3 when I rationalize the denominator. And be sure to recognize that when I circle all those negative values, again, like I knew, sine and its reciprocal, the cosecant, but of the basic functions, those are the only ones that are going to be positive in quadrant 2. So that's it. When you have to find the exact trig values of a number, that treat that number as an angle on the coordinate plane, on the unit circle. Find the reference angle, draw your reference triangle, find your ordered pair. That'll tell you x and y, and x and y is all you need to find all the 6 trig functions. And that is it.